Here we have the piecewise function of f of x equal to 2 minus x if x is not equal to 1, and then f of x is equal to 4 if x is equal to 1. What this right here says is y f of x is the same as y. Y is equal to 4 if x is 1. So that means we have the point 1, 4. And then f of x will be the line x2 minus x for x not equal to 1. And so this is what the graph looks like. We have the point 1, 4, and because it says that y is equal to 4 if x is equal to 1. So we have the point 1, 4. And then we have the line 2 minus x. This is the line 2 minus x if x is not equal to 1. And so at x equal to 1, we have a hole. And so this is the graph for this piecewise function. And we want to show that the piecewise function is discontinuous. At x equal to 1. And so to show that the function is discontinuous at x equal to 1, we have to show that one of these conditions fails. And so first we need to do f of a. So f of 1 is equal, no, this is x equal to 1. So when x is 1, y is 4. So that's what this says right here. So f of 1 just means x is equal to 1. What is y? And so when x is equal to 1, y is 4. And therefore, since f of 1 equals to a real number, it equals to a real number 4. And we say that the function f of x is defined at x equal to 1. And so the function is defined at x equal to 1 because f of 1 is equal to a real number. And so that's what it means. And then next we need to, so condition number 1 is met. And now we need to go to condition number 2. And so we need to find the limit this limit right here exists. So let's number these. So this is condition number 1, and then number 2. And to show that the limit exists, we need to show a limit from the left and limit from the right. And they have to be equal in order for the limit to exist. And so first, we need to do, since we're trying to show x is 1, and so a is 1, so we need to show the limit from the left of 1 and if we look back at the graph right here, this is 1 right here. If we approach 1 from the left, and so this is 1, and so we are to the left of 1. Which means x is not equal to 1. And since we're to the left of 1, x is not equal to 1, so we use the piece 2 minus x. So f of x will be the piece 2 minus x. And as x approaches negative 1, approaches 1 from the left, then 2 minus x will approach 1, because 2 minus 1 is 1. And now let's approach x. Now we'll let x approach 1 from the right. And same thing, if we approach x from the right, that means we are not 1. That means x is not 1. And therefore the limit the f of x, since x is not equal to 1, then we use the 2 minus x piece. Because if x is equal to 1, then y is equal to 4. So it'll be 2 minus x. And again, as x approaches 1, then 2 minus x approaches 2 minus 1, which is 1. And therefore we have limit from the left of 1 is equal to 1. Limit from the right of 1 is also equal to 1. And therefore the limit at 1 is equal to 1. This is equal to 1. And so we have condition number 2 is met, and therefore, and limit, since equal to a real number, then we say that the limit exists. In this case, it's the real number 1. Now this limit right here exists. But now we need to verify also condition number 3. We know that the limit, and here 8 is 1, so let's change that to 1. The limit of f of x as x approaches 1 is 1. And f of 1 is 4. And so what that means is that 1 is not equal to 4. And so condition number 3 fails. And therefore so we have condition number 1 is met, condition number 2 is met, but not condition number 3. And therefore the function f of x is discontinuous at x equal to 1. And again, we can see right here at x equal to 1, we have a hole right here, so that's why the graph is the function is discontinuous. But other than that, the f of x is continuous everywhere except x equal to 1. And this is how we write it using interval notation. It'd be negative infinity, comma 1, and then union 1, comma infinity.